Hey, everyone! Welcome back to the channel where we explore the biggest discoveries in the universe and what they mean for us. Today, we're diving into one of the hottest topics in space science. Right now has the James Webb Space Telescope, JWST, just confirmed extraterrestrial life on the exoplanet K2-18B. Grab your spacesuits because this journey will blow your mind. Let's break it all down. The James Webb Telescope may have detected the first signs of extraterrestrial life on the distant exoplanet K2-18B. Specifically, it found traces of dimethyl sulfide, a sulfur compound that, on Earth, is typically produced by living organisms. But how did scientists manage to detect potential biomarkers in the atmosphere of a planet light years away? Could we be on the verge of answering one of humanity's oldest questions? Are we truly alone in the universe? And if life does exist out there, why haven't they made contact with us? This question isn't new. It's at the heart of the Fermi Paradox, which was first proposed in 1950 by the renowned physicist Enrico Fermi. The paradox highlights a frustrating contradiction, given the vast number of stars and planets in the universe and the seemingly endless time for civilizations to evolve. Why haven't we found any trace of extraterrestrial neighbors? Officially, we're still waiting for that undeniable evidence. Yet, as we all know, countless videos and stories circulate online showing bizarre sightings of unidentified flying objects. We often hear about mysterious objects that seem to defy explanation, things that are literally not of this world. There are also intriguing claims from individuals like David Grush and Bob Lazar who assert that the U.S. government has been secretly recovering UFOs for decades. However, before we dive into the realm of speculation, let's focus on the officially confirmed facts. Despite all the Voyager golden records and the infamous WOW signals, we still have no solid evidence of life beyond Earth. This raises a fascinating question. Could we really be the only life forms in the vast universe? Given the countless stars scattered across the night sky, it seems almost impossible, doesn't it? Many researchers firmly disagree with the notion that Earth is unique in its ability to host life. Among them are Tom Westby and Christopher Canellis from the University of Nottingham. In a groundbreaking astrophysics study, they concluded that as many as 36 advanced civilizations might be lying in wait within our own Milky Way galaxy. They suggest that the reason we haven't encountered these civilizations yet is due to the immense distances separating us, with the average distance between potential alien societies being around 177,000 light years. Just to clarify, a light year is the distance light travels in a vacuum in 1 year, a staggering 9.46 trillion kilometers. While theoretical astrophysics can provide fascinating insights, are there more practical ways to explore this profound topic? The answer is a resounding yes. For the past 2 years, the James Webb Space Telescope has been shining a light on the universe's deepest secrets, revolutionizing our understanding of cosmic phenomena. This powerful instrument has reminded us just how distorted our previous perceptions of the universe really were. As the most advanced space telescope ever created, Webb is capable of detecting the heat emitted by a bumblebee on the moon's surface all the way from Earth. But while it could technically find those adorable insects, the telescope is more focused on revealing stunning images from the far reaches of space. Just take a look at the breathtaking James Webb Deep Field or the mesmerizing pillars of creation. Since its scientific mission began in the summer of 2022, the James Webb has also unveiled several intriguing mysteries about the cosmos, leading to exciting discoveries that continue to shape our understanding of the universe. A remarkable series of early galaxies has emerged that seem far too large and massive for their time of origin, just a few 100 million years after the Big Bang. This discovery challenges our current understanding of cosmology in striking ways. Additionally, the data gathered by the James Webb Space Telescope may help us delve deeper into the perplexing mystery known as the Hubble tension, which questions why the universe is expanding faster today than our theories suggest. But there's more to explore beyond the galaxies. Out there in the constellation Leo, approximately 125 light-years from Earth, lies an intriguing exoplanet called K2-18B. This planet has captured the imagination of scientists and stargazers alike, as it's suspected to host a fully developed ocean world. However, there's a small yet crucial caveat. These so-called ocean planets currently exist only in theory. While the idea of a habitable exoplanet covered in water is exciting, we're still waiting for official confirmation. Nevertheless, the data collected so far paints a compelling picture that K2-18B could indeed be a wet and vibrant world. Observations from the Hubble, Kepler, and Spitzer space telescopes, gathered even before the Webb era, suggest that this distant planet might just be a paradise waiting to be explored. The data is compelling. It suggests that K2-18B's atmosphere is rich in water vapor. This discovery is significant because the presence of water in a liquid state is a fundamental prerequisite for the emergence of life, much like we see on Earth. Nestled in the habitable zone of its star system, K2-18B has the right conditions to support this crucial element. This intriguing exoplanet orbits its host star, a cool dwarf star known as K2-18, at a distance that makes liquid water possible. Specifically, K2-18B is just about 0.14 astronomical units away from its star, allowing it to complete an orbit in only 33 days. Despite this close proximity, K2-18 emits considerably less energy and heat than our Sun, which means K2-18B receives almost the same amount of radiation as Earth does. But here's where things get interesting. K2-18B has a mass that's 7 to 10 times greater than our home planet, classifying it as a super-Earth. However, it's essential to clarify that this term only pertains to its mass and not necessarily to its habitability. So while K2-18B holds exciting possibilities, we still need more data to determine if it can truly support life as we know it. Is there extraterrestrial life on K2-18B? We've known about this intriguing exoplanet since 2015, but it's only in recent months that we've discovered its atmosphere contains dimethyl sulfide, or DMS for short. To grasp the significance of this groundbreaking discovery, let's revisit what we discussed earlier. On Earth, DEMS is primarily produced by living organisms, especially microorganisms like phytoplankton. It plays a vital role in our atmosphere, acting as the main source of atmospheric sulfur and even helping to seed clouds. Plus, it gives off that familiar oceanic scent we all recognize. The fact that data collected by the James Webb Space Telescope, specifically through its near-infrared spectrometer, revealed spectral signatures of methane, carbon dioxide, and DMS was hailed by lead researchers from the University of California, Riverside, as the proverbial cherry on the cake. If astronomers have truly detected DMS on K2-18B, it could be a strong indication of extraterrestrial life. So why are scientists still exercising caution despite these promising findings? The reality is that while the evidence is exciting, we have yet to confirm the existence of our extraterrestrial neighbors. The cautious approach in officially announcing the detection of DMS on K2-18B is largely due to the captured signal being relatively weak. This intriguing compound only emerged when experts evaluated the Webb data through a very specific lens. To further investigate these promising findings, researchers decided to reconstruct K2-18B, simulating its vast ocean and atmosphere using several models. They aimed to determine how much DMS the hypothetical organisms on this water planet would need to produce for it to accumulate in the planet's atmosphere. Simultaneously, the team studied how quickly DMS would break down due to radiation and where it might be found within the atmospheric layers. In their quest to uncover the secrets of life, the researchers made an exciting discovery. Biogenic sulfur gases could indeed accumulate to detectable concentrations on hydrogen-rich planets like K2-18B. However, for this to happen, the organisms on K2-18B would need to be significantly more industrious than those on Earth, producing DMS levels that are 20 times higher than what we see here. The reason for this heightened production is quite straightforward. A significant amount of DMS is broken down almost instantly by infrared radiation through a process called photochemical decomposition. However, if the concentrations of DMS are elevated, something that wouldn't be unusual for an ocean planet, its degradation products can actually provide a protective effect. Molecules like dimethyl disulfide and methanol act like a shield, safeguarding the lower layers of the atmosphere and preventing further breakdown of DMS. But is there a way to gain a more direct understanding of DMS levels on K2-18B beyond these theoretical models? Fortunately, yes. However, we won't be using Webb's near-infrared spectrometer for this purpose. The reason? The DMS signal detected by the near-infrared spectrometer showed up at a wavelength of 3.4 micrometers, which overlaps with the methane signal, making it difficult to differentiate between the two. To tackle this challenge, researchers plan to utilize Webb's mid-infrared spectrometer in the future. This instrument operates in the mid-infrared range, precisely where DMS and its related compounds leave their signatures. With this powerful tool, scientists are hopeful that they can clearly distinguish DMS from other signals, unlocking even more secrets about K2-18B, unless, of course, something unexpected comes up. The scientists are determined to uncover the mysteries of life on K2-18B before the end of this year. With their efforts, we might soon discover what the atmospheric signatures of this distant world truly reveal, potentially confirming that we are not alone in the universe. K2-18B is an exoplanet located about 120 light-years from Earth in the Leo constellation. It's roughly 8 times the mass of Earth, falling into the category of a mini Neptune. This planet orbits its red dwarf star, K2-18, in the habitable zone, meaning conditions could support liquid water. Scientists have been particularly interested in K2-18B because of its potential to host life. While it's far from being Earth-like, its atmosphere and proximity to its star have raised questions about whether this planet could harbor conditions for alien life. But now, thanks to Jwst, we might be closer to some answers. The James Webb Space Telescope has revolutionized the way we look at distant worlds. Launched in December 2021, it's the most powerful space observatory ever built. One of JWST's capabilities is detecting the chemical composition of exoplanet atmospheres, thanks to its advanced infrared sensors. By studying how light from the host star interacts with the atmosphere of K2-18B, scientists can pick up clues about gases like methane, carbon dioxide, and water vapor, all of which are critical for understanding whether life could exist on a planet. And recently, JWST's data from K2-18B's atmosphere revealed something that sparked excitement. In its latest observation, JWST detected a molecule called dimethyl sulfide, or DMS, in the atmosphere of K2-18B. Why is this significant? On Earth, DMS is produced by living organisms, primarily plankton in the oceans. Its presence in the atmosphere of K2-18B suggests the possibility of biological processes at work. While this is not direct evidence of extraterrestrial life, it's certainly a clue that has scientists buzzing. DMS is considered a biosignature gas, one that could indicate the presence of life. However, more research is needed to confirm whether this gas is indeed coming from biological sources or something else. The potential discovery of DMS on K2-18B is a huge step in the search for extraterrestrial life. However, it's important to note that this doesn't mean we've confirmed alien life just yet. Detecting biosignature gases is just one part of the puzzle. We need more data and follow-up observations to rule out non-biological processes that could also produce DMS. But the fact that JWST can detect such molecules on distant planets means we're entering a new era of exoplanet exploration. This discovery highlights the power of Jwst in identifying planets that may be more Earth-like than we ever imagined. Looking forward, scientists plan to continue monitoring K2-18B and other exoplanets with similar conditions. With Jwst's incredible capabilities, we can now study planetary atmospheres with unprecedented detail, increasing our chances of finding signs of life elsewhere in the universe. The search doesn't stop with K2-18B. NASA and other space agencies are planning missions to further explore promising exoplanets, and each discovery brings us closer to answering the age-old question: are we alone in the universe? Stay tuned, because this is only the beginning. The habitable zone is often referred to as the Goldilocks zone: not too hot, not too cold, but just right for liquid water to exist. For K2-18B, being in this zone is crucial. It raises the possibility of liquid water, which is considered essential for life as we know it. Understanding the parameters of this zone helps astronomers identify other potential candidates for hosting life. It's not just about being in the right location. The planet's atmosphere and surface conditions also play significant roles. While K2-18B shows promise, it's essential to compare it to other known exoplanets. For instance, planets like Proxima Centauri b and Kepler 186f have been candidates for potentially habitable worlds. However, K2-18B's detection of DMS sets it apart, adding a unique twist to its profile. Each exoplanet has its characteristics, making the search for life an exciting and dynamic field. Studying the atmospheres of exoplanets gives scientists a glimpse into their potential for hosting life. Gases in the atmosphere can indicate geological and biological processes. For K2-18B, the presence of DMS alongside other gases like water vapor can help build a clearer picture of its environment. As we push forward in the quest to understand K2-18B, AI will be our ally. Even if we find evidence of life on K2-18B, communicating with them poses challenges. The distance of 120 light-years means that any signals sent from Earth would take decades to arrive. Furthermore, the type of technology and language any potential life forms might use is entirely unknown. This raises interesting questions about how we would communicate and share knowledge across such vast distances. As we venture into this search, ethical considerations become paramount. What responsibilities do we have toward any discovered life forms? Should we attempt to communicate, or could that pose risks? The potential for contamination, either from Earth to the exoplanet or vice versa, is a concern that scientists take seriously. These ethical dilemmas need to be addressed as we explore the cosmos. Public interest in space exploration has surged in recent years. Events like the launch of Jwst have captivated audiences worldwide. People are eager to learn more about the universe and our place within it. This excitement helps drive funding and support for scientific endeavors, ultimately propelling us further into the stars. Engaging the public is crucial in fostering a deeper understanding of science and its implications. Studying Earth's ecosystems can provide insights into what conditions might support life on exoplanets. The diversity of life here, ranging from extremophiles in harsh environments to complex ecosystems, illustrates the potential for life in unexpected places. Understanding how life adapts to different conditions on Earth can help us speculate about the possibilities on K2-18B. In addition to the ongoing work with Jwst, several missions are planned to study exoplanets in the near future. The European Space Agency's ARIEL mission aims to analyze the atmospheres of a wide range of exoplanets, providing further insights into their composition and potential for life. These missions will complement the findings from Jwst and broaden our understanding of distant worlds. Social media plays a vital role in sharing discoveries and engaging the public in science. Organizations like NASA and ESA use platforms like Twitter, Instagram, and TikTok to share real-time updates, exciting discoveries, and educational content. This direct communication fosters a community of space enthusiasts, making science more accessible and engaging for everyone. As we learn more about potential habitable worlds, the concept of space tourism is becoming increasingly popular. Companies like SpaceX and Blue Origin are pioneering commercial space travel, and one day, private citizens might journey to exoplanets or their moons. While K2-18B might be a stretch for immediate travel, the idea of visiting other worlds fuels our imagination and inspires future generations. Space exploration has profoundly influenced culture, inspiring countless films, books, and artworks. As we make discoveries like K2-18B, they find their way into popular culture, shaping our understanding and perception of the universe. This cultural dialogue serves to inspire curiosity and wonder about what lies beyond our planet. The search for extraterrestrial life is a collaborative effort involving scientists from around the globe. Researchers share data, findings, and expertise, contributing to a collective understanding of the universe. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.